Okay, it says we're recording. Let's start sharing. Okay. So chapter 17, we're going to talk about the language of hypothesis testing. Now, so confidence intervals and hypothesis tests are kind of two different ways to do the same thing. So we're going to start with this. So you and a friend are going to play a game with a coin flip. Heads you win, tails your friend wins. So the coin comes up tail, 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 tail. The question is your friend cheating? And so we could figure out what is the probability of 5 tails in a row. So you probably all realize that the probability of coming up a tail on the first try is 1/2, and still 1/2, and 1/2, and 1/2, and 1/2. And so if we do that, got the answer right here. The probability of getting 5 tails in a row is pretty small. It's actually only is going to happen 3% of the time. Now, if we perform this 100 times, it will happen about 3 out of 100 times you will get 5 tails in a row. Okay? So the question is, if you did this 100 times, you might feel pretty good about saying, hey, you're cheating me. Five heads, it only comes up tails 3% of the time if you flip it 5 times. So you might be pretty confident that you could call your friend a cheater, but the friend might not be cheating because it will happen 3 times out of 100. So anyway, this kind of leads to hypothesis testing. So the idea here is we're going to have a null hypothesis. Typically we represent that as H sub 0. The null hypothesis is a statement of no change, no effect, or no difference, or in this case, it might be a fair coin. So we always assumed that the null hypothesis is true unless evidence indicates otherwise. The null hypothesis almost always has an equal sign, okay? And it's often not directly stated in the problem. So it's always about the parameter. It's never about the sample. So once again, you're going to have to figure out what's the difference here. Examples of your parameter are going to include P, mu, sigma, D, R, and M. We're going to focus mostly on P, on mu. Yeah, that's probably it. You can do it on other ones, but we probably won't. We'll be focusing mainly on those two. Examples not to use: you should never use P hat or X bar or S or D bar or R hat or B sub 0. So the alternative hypothesis. It's a statement we are trying to find evidence of or support. It is often stated in the problem. Okay. So now, one of the things that's a little hard for students is a lot of times the null hypothesis is implied. The alternative hypothesis is usually stated in the problem, and so people think that because it's stated, it's the null, but it's usually the alternative. So we're going to use H sub 1 or H sub A. Different books use different things, and I don't care what you use, whether it's H1 or HA. I will use them both. It doesn't matter. Okay, so there are 3 ways to look at hypothesis testing. You can do a two-tailed test where the null hypothesis is always going to be the parameter, which is probably going to be either P or mu, equals some value. And the alternative hypothesis is the parameter doesn't equal some value. You could do a left-tailed test. Your null hypothesis is going to be the same, but in this case, your alternative hypothesis is going to be a less than some value. Or you could do a right-tailed test where your parameter equals some value and your alternative hypothesis is greater than, okay? So let's do some examples here. And I want you to tell me, so one of the things that students hate to do is they hate to decide, do I put the letter P or the letter mu here? And so then they'll just say, well, I'm just going to get it half. I'll just ignore that and I'll put equals whatever. And that's good for half credit. But if you want full credit, you have to give me the correct parameter, either P or mu in most cases. Although we'll do some examples where it's not just P or mu here, just to get you used to it. But all right. So let's say here, this is our first example, and I want you guys to tell me, number one, are we using P or mu or something else? And number two, what does it equal? Okay. So I'm going to start picking on you guys right off the bat here. Okay. All right. So a pharmaceutical company has just developed a new antibiotic for children. Other similar antibiotics show that 2% of children experience headache as a side effect. The FDA wants to know if the new antibiotic is more than 2%. So let's go with the null hypothesis first, or the alternative hypothesis, okay? Now, the first question is, what letter do I pick? Am I going to pick P or mu or sigma or something else? So, Easton, what do you think? Let's pick on you first.
I would say P.
Why would you say P?
Because I don't feel like it's mu, but I could be wrong.
Okay. So, just to make sure you either have more or less confidence in your decision, one of the questions that you may want to ask before you do this, are the data quantitative or categorical?
It's quantitative, so it should be mu.
Why do you say it's quantitative?
Because it's 2% of children experience headaches as a side effect. I don't know.
Okay. Now remember we talked about this a couple weeks ago and it was really easy and now it's getting hard again. So here's what we're going to do. We are going to do a poll here. And so we're going to say data quantitative or categorical. So give me a thumbs up. And I'm going to blow my nose while you're waiting. I'm going to take this off here for just a second. This one, okay? Okay, I got one vote in. So two for categorical. It looks like Easton's going back and forth. 3. How many people do we have here now? 1, 2, 3, 4, 5, 6. Whoops. So we're going with, it looks like we're unanimous then. Okay. So you all think it's categorical. Why is it categorical? And what are the categories?
Would it be you either experience a headache as a side effect or you don't?
Yes, that's correct. It's headache. It's categorical headache. Headache or not. Okay. So we are going to use P on this one. So P equals
2%.
2%, so 0.02. The alternative is going to be
P is greater than 2.02.
yes, they want to know if it's more than 2%, right? So that was pretty good especially for your first try. Okay. All right. Should we go to another one here? All right. So this is a one-tailed or a right-tailed test. I guess I should mention that. Whoops. All right. Okay. So Blue Book value for a 3-year-old Chevy Corvette is $37,500. Grant wants to know if the price is different in Miami. So the null hypothesis, the alternative hypothesis. So let's go with Wes this time. What do you think, Wes?
I would think that it's mu, because the wouldn't the population mean be 37,500?
Okay, so maybe I should ask this, so quantitative or categorical first?
Quantitative.
It's quantitative. And so because it's quantitative, you're going with a mu equals? Is that right?
Yes.
Okay. A mu equals what?
37,500.
Okay. And the alternative?
Mu does not equal 37,500.
Does not equal 37,500. So is this a one or a two-tailed test?
This is a two-tailed test.
Two-tailed test, yes. Two-tailed test. Okay. Anybody agree or disagree with Wes? Seth, what do you think? Do you agree or disagree?
I agree, but could you explain how it's a two-tailed test?
It's a two-tailed test because we use not equals here. So yeah, that's why I put that up there. Okay, two-tailed test. So when we talk about the two-tailed test, we're always talking about the alternative hypothesis. So since he used not equal to, it's a two-tailed. If he had used a less than or a greater than sign, it would be a one-tailed test. Or less than is going to be left-tailed, greater than is going to be right-tailed. Does that make sense?
Yeah.
Okay. All right. So well done, Wes. Okay. So standard deviation of a 64-ounce bottle of detergent is known to be 0.23 ounces. Company purchases a new machine and wants to know if there is less variability. So let's see here. Whose turn is it to pick on? Allie, what do you think?
Can you open up the screen with the, yeah, okay. So I think it is another mu test.
Okay. Let's back up for just a second before we answer that question. Is it categorical or quantitative?
It's quantitative.
Quantitative, okay. And do you think it's mu because?
Because it has like a standard deviation, like, or not standard deviation, because like it says like they have like one that's known to be 0.23 ounces.
Okay. And what's 0.23? So you think that's the mean?
Yeah. Oh wait, no, that's the standard deviation. No, the mean is 64.
Okay. So what's the null hypothesis?
It's 64. Wait. Well, it says that it's known to be 0.23. So would that be it then?
I don't know. You tell me.
Well, I don't know. I'm totally just guessing, so I wouldn't be able to tell you.
Okay. Well, so we've got a toss-up between the 64 and the 0.23. So let's look at the second sentence here for a second, because I think that gives you a clue. Company purchases new machine and wants to know if there is less variability. What does variability refer to?
Like, that it doesn't change as much.
What letter?
Variability. Oh, that's the sigma?
Sigma. So we're going to be using sigma on this one.
Oh, okay.
So what's sigma equal to?
0.23.
0.23. Forgot my equal sign. And your alternative?
If it's less than.
So whatever you pick the first time, you get to pick it again. So sigma is less than 0.23. So is this a one or a two-tailed test?
It's a 1.
One-tailed, and it's going to be a left-tailed because we've got a less than, correct? Okay. All right. Now, this is hard, isn't it? This is where the class gets really hard, really fast. Okay. All right. So we're going to talk about type 1 and type 2 errors. Okay. So we're kind of based on the first one. So let's say that we were just doing a coin flip, and so let's say that you would say that the null hypothesis was P equals 1/2. You think it's a fair coin. We're always going to assume it's a fair coin, even if you think I'm cheating. The alternative would be P does not equal 1/2. So if we do the experiment and we get 7 out of 10 heads, that's kind of a question mark as to whether the person is cheating, right? Or whether the coin is fair. So the type 1 error, okay, so remember we say, in this case, the probability of heads is 1/2. Now we got a p hat equals 0.7, right? Now, would you think that 7 out of 10 heads, would that be unusual or not?
Not really.
Yeah, it's not very unusual, right? Okay, so the type 1 error, it refers to alpha. Alpha is a type 1 error. Alpha refers to is when we would reject the null, okay? So we would say, you know what, my experiment, now realize this is a small sample, right? We've only done this 10 times. My experiment came up 7 heads, and so therefore I reject that the coin is fair, and I think the coin is not fair, okay? So if you rejected the null hypothesis, and you shouldn't have, if you, maybe the 7 out of 10, that's not that unusual, right? So we rejected that the coin was fair. We said we think that there's evidence that the coin is not fair, and we were wrong. The coin was fair, but we said it wasn't, okay? So that's what we refer to as a type 1 error. Type 1 error is to reject the null when you shouldn't reject the null. Okay? Now, so there's two mistakes that we can make. So I just told you the first mistake. You said the coin wasn't fair, and it was. So the other error that we can make is we could say the coin is fair, but the coin wasn't fair. Okay? So the type 2 error says do not reject the null when you should have. Okay? We're going to use the same experimental values. Okay? 0.7. Okay? So we get 7 out of 10 heads. You said, I don't think there's enough evidence the coin is fair. But in fact, you examined the coin later and there was some tape on it or something, and the coin was not fair. Okay? So you say, type 2 error says, you do not reject the null, but you should have. So you said that 7 out of 10 is not enough evidence to reject that the coin is fair. But the reality was it was an unfair coin. And so we've got this thing here, okay? It could be that the coin is fair, and you do not reject the coin as fair, and so that would be a correct conclusion. It could have been that the alternative was true. The coin was not fair, and you properly rejected the null. That would also be a correct conclusion. Okay? Now there's two ways you can be right. You said there's the null is true and it was true, or you say the alternative is true and it was and that was true. Okay? And so those are both correct conclusions. The two mistakes you could make are you say the coin is fair, the null is true, but it wasn't fair. Actually, I said that wrong. The null is true. Okay, so the coin is fair, but you said the coin was not fair. That would be one mistake. Or you could say there's not enough evidence to reject the null, but in reality the alternative was true. Okay? So we refer to a type 1 error as alpha, and we refer to a type 2 error as beta. Okay? Now the question is, if you're going to make a mistake, which is the better mistake to make? Okay? So let's go here and talk about the pros and cons. So we'll use that same example we used before. The pharmaceutical, sorry, excuse me, just one second. I think my allergies are acting up this morning. All right. So a pharmaceutical company has just developed a new antibiotic for children. Other similar antibiotics show that 2% of children experience headache as a side effect. The FDA wants to know if the new antibiotic has more than 2%. So as we talk about this, okay, so we talked about this earlier. Actually, maybe I can pull this up. Okay, so the null hypothesis is you've got 2% of kids that get a headache as a side effect. Okay, the alternative is the FDA wants to know if there's new antibiotic. So I'm going to throw this out for anybody. Type 1 error generically is to reject the null when you shouldn't. So in the context of this problem, what does that mean?
Is that saying that you think that it has a percentage of headaches that's greater than 2?
Yes, you think that the more than 2% of kids get headaches. Okay, so the idea here is let's say that we're going to call this as safe, and the alternative would be unsafe. So you would say that the new antibiotic is unsafe, correct? When in reality it was safe. Okay? So you said it was unsafe, but it was really safe. Now, let's talk about the type 2 error. This is the other mistake you could make. It says do not reject the null when you should. Okay? In the context of this problem, what does this mean?
You say it's safe when it's not.
You say it is safe when it is not safe. Okay? You think only 2% get headaches, but more than 2% do. Okay? So, which mistake, if you're going to make a mistake, which mistake would you rather make? Would you rather make a type 1 error or a type 2 error?
In this instance, a type 1.
Type 1, right? Because if you make the type 2, you get sued, right? You get sued and bad publicity. In step 1, you don't make any money, but you keep your reputation. Okay? So typically, if you're going to make a mistake, it's the type 1 error that we're more interested in making because it's the safer mistake to make. Okay? So type 1 is the safer mistake to make. Okay? And that's going to be the one that we're going to concentrate on. Other than this chapter, I want you to understand what the difference is between a type 1 and a type 2. But we're going to concentrate more on the alpha than we are on the beta. Okay? If you want to learn betas, come take my Math 2040 class. I'm teaching it next semester, by the way. And I'm sure Easton's going to be signing right up, aren't you? Okay? All right. So, okay, so another thing that I want to talk about with the null hypothesis, we always reject the null or we do not reject the null. We never use what I call the A word. Okay? Students love to use the A word, and I'm going to pretend it's a swear word. I'm not even going to say it, but I wrote it down. Okay? No swearing in my class. Okay? So, the reason why is because, going back to here, okay, you do your experiment, you get 7 out of 10 heads, your p-hat is 0.7. We would rather reject the null or not reject the null. We would never accept the null. First of all, this is not very much evidence, right? 7 out of 10 heads, okay? So we would not accept that sorry, I just swore. We would not accept, you're supposed to laugh. We would not accept that the coin was fair. We would either reject that the coin was fair or we would not reject, okay? This is one of those weird things that statisticians do, is we reject or we do not reject the null, okay? We never accept, okay? Any questions on this? All right. Now, I got done really fast with this section. But what I would like to do is, because I think you guys are all going to have lots of questions. And let me see, do I have a thing? I thought I saw something there. No, guess not. So here's what I would like to do. Your chapter 17 homework is going to be basically finding the null and the alternative hypothesis, okay? And type 1 and type 2 errors. And I will say this is one of the hardest things that you're going to do in this class. And notice there's no math involved. I'm not going to make you do a lot of math, okay? But what I would like to do is I would like to, and I'm going to open this up here. I would like to give you a outline. I don't know which one I want to look at. These have the same date and different times. What's the difference? Where's my outline? Oh, here it is. This is what I want to do. I'm going to give you a copy of this outline here. Because this is going to basically, so there are 7 steps that I want you guys to come up with when you do hypothesis tests. So let me just stop here for a second. Does anybody have any questions on what I've covered so far? Because this is what your homework is going to be on. What I'm about to cover is going to prepare you for everything we're going to cover for the rest of the book. And I'm going to do it all at once. And then we're going to hopefully repeat it and repeat it and repeat it. And then hopefully it's going to get in your brain. But I'm just going to warn you right now, when I said that this next test is going to be really hard, this is what I'm about to show you is why. Okay? So do you have any questions about what we've done so far today? Okay? So we're going to repeat this, but and in fact, okay, so I've taught you everything that you need to know for chapter 17. And we're going to kind of review this today. And then basically I want you to have, I'm going to put, these steps are in 8 steps, okay? So if for those of you who are taking notes, these are the 8 steps that I want you to do, okay? And then we're going to go through an example. But the 8 steps are, when we're doing, so how to pick the right hypothesis test, okay? Essentially, the rest of the semester, what we're going to do is I'm going to show you 3 or 4 different hypothesis tests. And the reason why it's so hard is because you're going to have to pick the correct test, okay? So there's 8 steps that I want you to do. Step number 1, I want you to list all the numbers from the problem. So we've been kind of doing that, the n's, the x's, the p's, the p-hats, the mu's, everything like that, okay? Also want you to know, to check and say, is our sample size large enough as part of this? Okay, so I'm going to review this example in a minute. Step number 2, I want you to tell me if the data in the problem are quantitative or categorical. Okay. Step number 3, I want you to find the null and the alternative hypothesis. You should all be experts at this now. You've had, 45 minutes of training, so you're all experts, right? All right, step number 4 is I want you to pick the correct statistic. Okay, there's going to be 3 well, three main ones we're going to talk about. We're going to talk about a z-test, we're going to talk about a t-test, which we haven't talked about yet, and we're going to talk about a chi-square test, which we also haven't talked about yet, okay? And we'll go over this in more detail, but this is where we're going. Step number 5, so pick the correct statistic, and then not only do you have to pick this, whether, excuse me, whether it's a z, a t, or a chi-square, but then you have to do the calculations, okay? We'll talk about that in a minute. Once you've got your z-score or your t-score or your chi-square score, you need to find the p-value. This is chart or computer. We're not going to do the computer, though. We're just going to do the chart, okay? Then we're going to compare our p-value to alpha. That's step number 6. If it's not stated in the problem, assume that your alpha is 0.05. And sometimes I forget to ask that. So if I forget, assume your alpha is 0.05. Okay, that's your type 1 error that we just talked about. Step number 7, you have to decide whether to reject or do not reject. We never use the A word, even though I spelled it out for you there, okay? And then this is also the most horrible part about this is when students get the first 7 steps correct, and then they have to write, you have to write your conclusion in English, not statistician, and essentially, I want you to use plain English. I don't want you to use reject, do not reject, hypothesis, or any of those words. We're going to say, is your friend cheating? Is your friend not cheating? Okay. Nobody before today had ever heard of null hypothesis or alternative hypothesis or accept or reject or anything like that. So I want you to write it in English, not statistician. So it's frustrating when everybody gets the first 7 steps right and then trips at the finish line and writes the conclusion wrong. But it happens every semester, okay? So those are the 8 steps. So what I would like to do is we're going to do a few different examples here today. Your homework is basically going to stop at step number 3, but I would like to introduce you to this as well, okay? All right. So, example here. You want to know if your friend is cheating while flipping a coin, okay? You flip the coin 10 times, it comes up 7 heads, okay? So, first thing we're going to do is we're going to list all the numbers, okay? So, you flip the coin 10 times, so your n is going to be 10. Your sample size is 10, which already we know, hey, that seems a little bit too small, okay? Comes up 7 heads, so your x is 7. So your p-hat is going to be 7 divided by 10, which is 7/10. Okay? Now, if we know our p-hat, this is where, maybe I should ask this question first. I probably should have swapped these two. Every semester I do these, I'm like, I don't know. So maybe we should ask ourselves first, is this data quantitative or categorical? It's categorical because we're talking about heads or tails. Okay? Hopefully that will help us pick these, okay? So since it's categorical, I'm going to use P equals 0.5 because I always assume the coin is a fair coin until there's evidence that proves otherwise. Now, because it's categorical, I should also notice if my sample size is big enough, okay? So if I take 10, so NPQ, so 10 times 0.5, which is P, and 0.5 is also Q, is only 2.5, okay? So this is actually too small of a sample size. So I shouldn't use the method that I'm going to use, but I want to keep this as a simple example. But so this is way too small to be doing, to use the central limit theorem, okay? So I should not be doing this, but I'm going to do it anyway just for fun. But my sample size is too small, and so this means that your results are likely to be contested. Okay. Any questions so far?
I don't know about for everyone else, but I can't see the screen that you're using right now.
Oh, really?
Frozen.
You're just frozen?
Yep, you're good now.
Oh, that's weird. I didn't do anything. Okay. All right. Okay, so steps 1 and 2, by the way, these don't necessarily have to be done in order. Just make sure you do them all. And you may want to choose the categorical quantitative right off the bat as step number 1. Or, well, it might help you. These two steps kind of go together. So, all right. So step number 3 says to find the null and the alternative hypothesis. And hopefully you guys know what that is, but I think you probably need more practice. So this time, we're going to pick on Janie. Janie, can you help me find the null and the alternative hypothesis on this example?
I can try.
Okay.
So, wouldn't the wouldn't it be where we use the mean?
Carrie, what's the mean?
It's 7.
Okay, so let's review again. The null hypothesis is a mathematical statement or equation that always means no change, no difference, or a fair coin. It's always about the population. Common variables are p, sigma, and mu. It almost always has a equal sign. It's often not stated directly in the problem, and it means a statement of no change, no difference, or the coin is fair. So if they're getting 7 out of 10 heads, does that tell me I have a fair coin?
No.
No. So what would indicate a fair coin?
Wouldn't it be if it was like 5 out of 10?
Okay, so what's 5 out of 10?
%.
Okay. Well, I don't care whether you put 5 out of 10 or 0.5 here. But what I was asking for was what's the letter that I'm supposed to put here? Because you got half credit so far.
Shoot. Oh, it would be your P.
Why is it P?
Because, well, the number right there says P equals 0.5.
Okay, which can make it very helpful when you're doing your numbers. That's why we list the numbers, okay? Now, the one thing that I want to say is that at first you said it was the mean.
Yeah.
But now you've changed your mind and you've said P, okay?
Yeah.
Okay, so remember, mean would refer to mu, right?
Mm-hmm.
But we're not really talking about a mu. We're talking about a proportion out of 100%.
Yeah.
So, and it's categorical. It's heads or tails. So we're going to use P on this problem. Okay? All right, now you want to know if your friend is cheating while flipping a coin. So what's the alternative here? So this, what do you think?
So would it be greater than 50% or like?
We haven't really defined what's a head and what's a tail, right?
Oh, yeah.
Okay. So we don't know if P is going to be greater than 0.5 or less than 0.5. Because we didn't really define it very well, did we?
No.
Okay. So what do you think the alternative is?
So would it be like P is greater than or equal to, or greater than or less than?
Yeah, so you could either do it P is greater than, or P does not equal 0.5, or P does not equal 0.5, because I don't know how to make a not equal sign. Okay, when I'm typing. When I was doing this, so okay, so that's good. So these are hard. Steps 1, 2, 3 is the hard step, right? So far. Would you agree with that?
Yes.
This is going to be hard homework, okay? And we're only doing the first 3 steps. Well, we might do a little bit more than that, but all right. So very good. Okay, so this is a good review. So in our case, P equals 0.5. Alternative is usually stated in the problem, and in our case, it is. So let me back up a second here. 0.5 was not really stated in the problem. Do you agree with that? So that's another reason why that makes the null hypothesis hard, because it's not directly stated. You just know that you have to assume that you're using a fair coin. But the alternative, which I've just highlighted here, is stated. You want to know if your friend is cheating. Okay, that's your alternative hypothesis. It's not the null. You don't assume the null is they're cheating right off the bat. You always assume it's a fair coin. And we're trying to decide if 7 out of 10 heads is enough evidence to show that they're cheating. Okay? Making sense so far? I will post this again because I know you guys will love this, okay? And look, there is a not equal sign, but I can't find it easily on my keyboard. Okay, so at this point, this is going to be the new hard part of our next section, okay? Pick the correct test statistic, okay? Now, you'll probably want to memorize this. In fact, I would say this is probably what you're going to want to do, okay? You're going to have 3 choices. Is it going to be a Z? Actually, you're going to have more than 3, but anyway, 3 main choices. Is it going to be a Z? Is it going to be a T? Is it going to be a chi-square? Okay? If the data are quantitative, then, so look, quantitative, 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 and then we've got 2 categoricals here, okay? So this is why picking out step 2, is it categorical or quantitative? This is where you're going to use the answer to that, okay? If it's quantitative and you're measuring a mean, then it's going, and I know, so there's 3 things here. If it's quantitative, you're measuring a mean, and yes, I know the population standard deviation, then it's going to be a z-test, okay? If it's categorical and you're measuring just one sample proportion, it will also be a z-test. Now these 2 are different equations, but in both cases they'll be a z-test. Okay, next time in class we're going to learn about the t-test. I'm just going to introduce it to you a little bit now, okay? If it's quantitative and it's a 1 mean and I do not know the population standard deviation, then it's going to be a t-test. I know I haven't taught you that yet, just go with it for now, okay? I'm not going to teach you today, I just want to make sure you get the basics down. Also, if it's a 2 means, if we're going to be measuring 2 different means, then it will also be a t-test, okay? So your t-test is going to be a 1 sample mean, quantitative, you don't know the population standard deviation, or it will be a 2 sample mean, okay? Third option is the chi-square test, okay? This is known as the chi-square test of independence. It's on categorical data, but you have more than 1 population proportion, okay? You could have 3 or 4, okay? And in that case, It's going to be a chi-square test of independence. It's also going to be on categorical data, okay? So you will definitely want to memorize step number 4 because it'll make your life easy if you memorize that, okay? Now, how do you decide between the z-tests, okay? Which is what we're going to be concentrating in, I think the next, I don't remember, next 1 or 2 class periods, okay? So many proportions are categorical, but not always. Means are always real numbers. You can always figure out the standard deviation on a proportion, even if it's not stated in the problem, okay? So in our case, we're using categorical data. It's a 1 sample proportion. We're going to use the z-test for proportions, okay? Which is going to be p hat minus p over the square root of pq over n, okay? Now remember, we said our sample size was too small, but I'm doing this anyway, okay? So your p hat was your experimental probability. We got 7 out of 10 heads, okay? So that's your p hat minus your p. We assume it's a fair coin. We're going to divide it by the square root of pq divided by n. P is 0.5, Q is also 0.5 because it's 1 minus P divided by 10, okay? So this is the correct equation to use in our case, okay? That's going to give me a z-score of 1.26 standard deviations away, okay? Now we need to find the p-value, okay? So we're not going to do it with the computer. We're only going to use the chart. So you have to ask yourself, is it a right tail, a left tail, or a two-tail test? Okay. Pictures are going to be very helpful because the question is, do I have to double it, which you will have to do with a two-tail test? Do I subtract it from 1 or do I not subtract it from 1? If you don't know the picture, you're going to get this wrong probably, okay? So in this case, okay, I've got 3 pictures here. If it's a left tail test, remember when you're looking at your chart, I need to find my chart. What I'm going to do. Here we go. Okay. So your normal distribution. When we're looking at it, normally it gives you the area to the left. Okay, now let me just show you something. I know I haven't taught you the t-distribution. We're going to introduce it very briefly today. T-distribution gives the area to the right. So make sure when you're trying to decide whether it's a z or a t, does it give you the area to the right or to the left? Okay, that's going to make a big difference. And so if you're using a z distribution or a normal distribution, you're going to take it to the area to the left. If you're using a t-distribution, it's going to give you the area to the right. So, and the chi-square distribution, I'll show you that here. Chi-square is not is going to be weird. It's not symmetric and it's going to be hard. Okay, I'll just warn you that right now. Okay. So anyway, if it's two-tailed, you're going to double your p-value. Okay. Now, because as we go back here, we said that p does not equal 0.5, so it's a two-tailed test, okay? So the idea here is, what we're going to do is we're going to draw our picture here. We've got a right-tailed, so we've got a two-tailed test. So since it's a two-tailed test, once we find our p-value, we're going to, oh, apparently this is my old notes here. We're going to double our p-value, okay? So we got a p-value of 1.26, okay? If I look here on my area, sorry, I look at my normal distribution. So I've got the area to the right, or to the left is 1.26, okay? So this is going to be a tricky one, okay? 1.26. Okay, in fact, let me draw my picture here. Do I have a paintbrush open? Okay, so here I'm going to erase my scales here. And I don't know what the area in the middle is here. Okay. Essentially what I've got a two-tailed test. Okay. Now we would say that P equals 0.5. Okay. Now we got a P hat that was greater than P hat equals 0.7. Okay, so we're on the right side. The problem is my table is giving me the area to the left. So when I look up this number here, 1.26, it gives me 0.8962. So what this is telling me here, let me draw another line here. So I've just converted, when I use my z-score equation, my z, this is going to be z equals 0, and now my p hat corresponds to 1.26 standard deviations away. The area to the left here, this area is 0.8926. 0.8926. Okay. Now, if I want the area to the right, how do I find this area over here? I'll throw that out for anybody.
You want the area to the right?
Yeah, we want the area to the right, and I know the area to the left is 0.8926.
So would you want a t-test?
Nope, we're using the z-test. We're sticking with the z-test today.
Subtract 1.
Subtract it from 1. So the area to the right is 1 minus 0.8926, okay? Which is going to equal 0.1074. Okay, so this area right here on the right side is 0.1074. Okay, now since my null hypothesis is P does not equal 0.5, okay, I need to double that value. Okay, essentially what we're saying is I want to double it. So I'm going to take this 0.1074, I'm going to double it, that going to become 0.2148 if I did that right. Maybe I should check my math and make sure I'm doing that right. So 1 minus 0.8926 is 0.1074. I'm going to take that and I'm going to multiply it by 2. So 0.2148. Oh, good, that's what I said. Okay. All right, so my p-value in this case here, oh, I wrote it there. Okay. So my p-value is 0.2148. Now, did I give you an alpha in this problem? I did not. So what do you assume your alpha is?
0.05.
0.05. Okay, so the idea here is, so I found my p-value. Now we need to compare it to alpha. If it's not stated in the problem, it's 0.05. Okay, so the idea here is we need to, so this is the phrase that pays. Okay, if your p-value is low, then you reject the HO, the null hypothesis. Okay, and so as we look at this, what we're going to do is we're going to compare your alpha to your p-value. So most often it's going to be 0.05, but you could also use 0.10 or 0.01. I will tell you that, just for fun, in genetics tests, the alpha is usually 1 times 10 to the minus 16th power, because there are so many genes in the body, and that's what they use. So the idea here is we're going to compare our p-value that we just found, 0.2148, to our alpha, which is 0.05. Okay. So okay, so we're going to compare those. So you have to decide at this step 7 whether you're going to reject or do not reject the null. We're never going to use the A word. And so here's the phrase. If the p-value is low, and we're always comparing our p-value to our alpha, then you reject the null. Okay? So is our p-value is 0.2148 less than 0.05? No. So therefore, we do not reject the null. Okay? So we do not reject the null. And we need to write our conclusion in English. Okay? So there is not enough evidence to conclude that the friend was cheating or that the coin is unfair. Okay? Now, I know that was a lot. Okay? So, let's do words I do not want in your conclusion. I don't want to see any of those words. Reject, null, hypothesis, or accept. So do not use those in your conclusion. You can use those on step number 7. That's fine, but I don't want those on step number 8. Actually, I never want to see the word accept ever. Okay? All right, so let's do another example here. And I'm going to have you guys tell me what did you guys write down the 8 steps?
Yes.
You did?
I'm not as good as Easton. I did not.
Okay. All right. So let's write them down really quick then. I want to make sure that you got them. Okay. Step number 1, list all the numbers. Step number 2, is it quantitative or categorical? I'll wait a second while you guys catch up. Okay, now, the reason why I want to do this, hypothesis testing is hard, and if you can't remember the steps, you're pretty much guaranteed you will not get them right. Okay, and so when we're doing these tests, I'm going to pretty much copy this format. The homework, sadly, this is kind of something I came up with on my own. And the homework is not going to have the 8 steps. But here's what I'm going to say. When you're doing the homework, especially for chapter 18, and I know this is kind of a preview to chapter 18, what I would recommend is you do all 8 steps and then you answer their questions, because if you do all 8 steps, you should be able to answer all their questions. Does that make sense? Okay. So step number 1, list all the numbers. Step number 2, is it quantitative or categorical? Step number 3, find the null and the alternative. Does anybody need more time to write that down? Who needs more time?
I'm good.
You good? Okay, step number 4. Pick the correct test statistic. Okay? And I would like you to write down the A, B, C parts because this is going to be the hardest one. The step 4 is the one that you really need to know almost like the back of your hand. So I'll give you a second to write that down. Who needs more time? Step 4 is probably the hardest step. And you thought finding the null and the alternative was hard, and it is. Do you need more time? You got it, Easton?
Yeah.
Okay. We'll move on to the next one. Step number 5, find the p-value. In fact, you know what you should add there? Draw a picture of the normal, typically the normal distribution. So you got left tail, right tail, and two-tailed. Step number 6, compare your p-value to alpha. And we assume it's 0.05 if it's not stated in the problem. Step number 7 is decide to reject or do not reject. And step number 8, write the conclusion in English, not statistician. 8 is also a very difficult step. Okay. Questions? Are we ready to ready to move on? All right.
Sure.
Okay, so we're going to do this one. This is the one that I've kind of walked you through, and I know that was a pretty easy one. But I want you guys to do this. So here's where we're going to start taking turns. We're down to 4 people. Well, you guys are the good stalwart people, I guess. Okay, so all right, you think people are speeding in a 30-mile-per-hour zone. Local police tell you the standard deviation is 4.6 miles per hour. You find the mean speed is 35 miles per hour for 15 cars over a half-hour period. It is known to be normally distributed. So step number 1 is what, Allie?
We have to decide if it's categorical or quantitative.
Okay, you went with step number 2, but that's actually, I don't mind that.
Okay.
Categorical or quantitative, that's fine. Because sometimes this might be helpful anyway. So what do you think?
So it looks like it's quantitative.
It's quantitative. Okay, well done. Okay, step number 2, or step number 1, as the case may be, is what, Easton?
Write down all the numbers.
Write down all the
List them.
numbers. Find the numbers. Okay, what are the numbers?
So N is going to be 15.
N is going to be 15. Okay.
X bar is going to be 35.
Okay.
Your sigma is going to be 4.6.
Okay.
And then $30 is what the mean should be.
Should be. So what are we going to call that?
That just mu.
We're going to call that mu. That's what the mean should be, correct? Okay. Anything else?
I mean, there's a half-hour period, but I don't know that really.
Yeah, that's just
Not
descriptive.
applicable.
Okay. How about, I didn't do this last time, but we probably should. What's your alpha?
0.05.
0.05, because we didn't state it, right? Okay. Well done. Step number 3 is what, Janie?
define the null and our alternative hypothesis.
Okay. What do you think that is?
Well, I was bad at this last time. Hold on. Is the null one, is that people going over 35 miles per hour?
I don't know. Did you write down all the things you should remember about your null and your alternative?
No, I didn't get them all.
Okay. So here, I'll write this down right here. So it almost always has an equal sign. It's about the population parameter. What else did I say? I can't remember. No change, no difference, fair coin. Well, fair coin doesn't matter in this case. Okay. No change, no difference. I'll ignore the fair coin because we're not dealing with the fair coin. Common variables are p, sigma, and mu, and it's often not stated in the problem. Okay. Often not stated in the problem, and common are p, mu, sigma. Okay, so there's your hint.
Okay. So would that be so if it's about the population parameter, would that mean it would be like about the 15 cars?
It would be about the 15 cars, but N is not one of the common ones that we're going to use.
Okay. So we'd probably use the mu then, right, for 30?
We'll use the mu, so it's a good thing that Easton figured out that mu right off the bat, right?
Yeah.
Okay, so mu equals
30.
30. Very good. Okay, so you owe Easton something.
Easton, your champ.
There we go. Alternative. Okay, alternative hypotheses. Often stated in a problem. What else do we have? I'll add another thing. Okay, it's often stated in the problem, usually less than, greater than, or not equal to. So those are your hints there.
Okay, so my the null alternative. So would it be like is should be like equal to, like not equal to 35 miles per hour?
Oh, okay, so here's another hint. Use same letter and value as in null.
Oh, okay. So then it's going to be not equal to, like mu not equal to 30.
Okay, so you're saying it's mu not equal to 30. Now, let me ask you a question. Read the problem again, and what do you think is happening?
Oh, people are going over 30 miles per hour?
So is not equal correct?
No, it would be the mu is greater than 30.
Greater than, okay, yes. So remember, it's often stated in the problem, and you think people are speeding. Okay, does that make sense?
Yeah, that does. Thank
Are you
you.
going to ace the homework tonight?
Maybe.
Okay. All right, we'll let you off the hook. Whose turn is it now? That was Janie, right? Wes, it's your turn. What's the next step?
To find the p-value.
Nope, you skipped a step.
Oh, to pick which test it is.
Pick
And
the
this
test.
one's Z test.
It's going to be a z-test. Z-test for a mean, right?
Yep.
Okay. So do you know the formula you're supposed to use for the z-test for the mean?
Yes. Z
Okay.
equals X bar minus mu over sigma.
Divided by the square root of?
N. Sorry.
Well done. Very, very well done. Okay. All right. So in this case, the numerator is going to be
Can you scroll your page up a little bit? I can't see what you're typing because the bar thing's there.
oh, sorry.
Thank you.
I'm trying not to give away the answers.
5 divided by 4.6.
So 35 minus 30 divided by
4.6.
4.6. Whoops. 0.6 divided by
15. The square root of 15.
square root of 15. Well done. We're going to plug that in our calculators, and you're all going to do that perfectly, and you're not going to make a mistake, right? And I need to make that. Okay, so that gives us a value of 4.209. Oh, that's interesting. Okay. So we got a z-score equal to 4.2 or 4.21, I guess, if I round that to 2 decimals. Okay, so this equals 4.21. Now, this was unfortunately lucky. How's that for a phrase? Okay, step number 5 is what? I think we're going back to Allie.
But I have a question about the z-score first.
Okay.
I thought, like, on the z table, I thought it only goes to, like, 3.4.
Ah, very astute observation. That's why I said we were unfortunately lucky. Okay? We'll talk about that just right now. But that was very good observation. Okay?
Okay.
Because you're already going to the z table. Why did you go there? Because step number 5 is what?
Find the z-score for it, like the percentage.
No, we already found the z-score.
Like the probability that, like, to the left.
P-value. Yeah, we're
Yeah.
going to call that the p-value. Okay, and as you notice, this is off the chart, right?
Yeah.
Okay, so what does that mean? Off the chart, okay? And normally, let's pretend, we'll pretend for a moment that it's 3.21, so it's not off the chart. What would you do if it was 3.21?
You would go to wherever the 3.21 is and find the p-value for that.
Okay, so you'd get 0.9993, right?
Yes.
Is that the correct answer?
No.
No, because?
We're supposed to do, like, the 1 minus, because we're looking for
Correct.
if it's above.
All right. Now, okay, so perfect. You answered that perfectly, but it's off the chart. It's 4.21. Okay, which is unfortunately lucky because I never remembered to tell students to do this, but we did today, so that's exciting. Okay, it's off the chart. Okay, the number here is 3.4. You can see it's 0.9998. Okay. So here's the deal. We're going to have to still subtract that from 1, right? So if it's off the chart, then your p-value, here's what I want you to do. Okay, now I don't know what the book's going to do, but on the test, I'm going to say, of course, you know you're taking that 0.9999 and you're going to subtract it from 1. So I want you to say your p-value is less than 0.001. Okay? Otherwise, you're going to treat this normal. Okay? So now the question is this one or two-tailed?
One.
It's a one-tailed test. So do I need to double this?
No.
No. Okay. So since it's 1, I can just go with this. And so you guys are really lucky that I did this one because it was off the chart. I usually forget to tell students, and then they give me a p-value of 0. And your p-value can never be 0. It can be very close to 0, though. But your p-value is going to be less than 0.0001. So, okay. All right, so well done. Step number 6 is what, Easton?
You compare it to alpha.
Compare it to alpha. Alpha. Oh my gosh. I'm trying to sell my mom's car, and I have a feeling that's what that phone call is, but I'll stop and they can leave me a message. And by the way, I'm selling 2 cars. If anybody wants a Ford Festiva 2015 or a Hyundai Sonata 2013, I'm selling 2 cars. Let me know after class. Okay, compare to alpha. So we said the alpha was 0.05. Now really step 6 and 7 kind of go together. Can you tell me step 7 as well, Easton?
Decide whether or not to reject or not reject the null hypothesis.
Or not. And do you remember the phrase that pays?
That we don't ever use the A word.
Okay.
If it's
that's true.
If it's less than alpha, then
Value
we
is
reject
less
the
than
null.
alpha. Reject. Well, that's not. That was a nice one. If the p-value is less than alpha, reject the null. If the p-value is low, reject the ho. Right? Or the null, because it kind of rhymes. Okay. So you're comparing this p-value to your alpha equal to 0.05. So do you reject or do you not reject?
We reject the null hypothesis.
Reject the null, okay. And then the next person gets the hardest step. Sorry, Janie. What's the last step?
So write your conclusion in English.
In English, okay. What are we trying to figure out? We're trying to figure out the answer to this question. You think people are speeding in a 30-mile-per-hour zone. What do you think? Are people speeding?
Yes, people are speeding.
That was a question, not an answer. You're supposed to be like, yes.
Not with math. I think I question everything I do.
Okay. So how confident are you in your conclusion?
I'm gonna give it like a 95% because the mean is 35.
Okay. The sample mean. So tell me again one more time. Tell me what to write.
Yes, people are speeding.
That still was a question. Yes, there is evidence.
Oh.
People are speeding. Okay. Do you agree, Wes, with Janie's conclusion?
No, because our p-value was less than the alpha, so we have to reject the hoe.
We
I'm
did
offended.
reject the hoe. Remember, the hoe said that the speed people were going 30, and we rejected that people were going 30. So we think the alternative is true. We think people are going faster than 30.
Can't we go back to math?
You should have agreed. You should have agreed with Janie. Well done, Janie.
And how do we make
Even
that
though it was a question, not a statement.
How do we make that conclusion based off of that, like the p-value, or is there some sort of guidelines for that?
So that was why I said if the p-value is low, reject the whole. Okay? Or reject the null. So we rejected the null. The null said people are not speeding.
So
we rejected that. We think people are speeding.
Okay, that makes sense.
Yeah. So remember, you're going back to step 3 when you're checking this. So the null says people are not speeding. You rejected that, and you think the alternative is true. People are speeding.
Yeah.
I have a question on it.
We're going to be doing this the rest of the semester. Every day it's going to be repeating these 8 steps, just with different equations, okay? So go ahead, Easton, you have a question.
So do we need to worry about the sample size, that it's only 15?
Oh, that was a good thing. I forgot to ask that question. You should. Yes, I'm glad you mentioned that. What about the sample size? Is sample size large enough?
Because shouldn't it, because it's quantitative, don't we generally want it to be greater than 30?
You generally want it to be greater than 30. Now, what are the exceptions to that?
If it's a normal distribution?
It is known to be a normal distribution. So since it is known to be normal, you can get away with a sample size of 1, believe it or not. But I don't know anybody in their right mind who would do a sample size of 1. You'd be stupid to do that, okay? But 15 is small. It's small.
I was just wondering, because if n was bigger, wouldn't our z-score would go down and the p-value would be bigger, right?
Yeah, so it is small, but okay since normally distributed. Okay, if this sentence was gone, then you shouldn't do it. Okay? You shouldn't even do the test. But since it's known to be normal, we got away with 15. Okay? So this is a good test question, because I will often ask you, is the sample size large enough? And you will say, yes, it's too small, but it's okay since it's normally distributed. And some of you are going to say, no, it's too small. And I'll be like, it is too small, but. But yeah, if this last sentence isn't here, it's too small. But it's okay since it's normally distributed. Okay? So excellent question. Oh, by the way, if you use the computer, your p-value is that number right there, 1.28 times 10 to the minus 5th. Okay? Are you excited for the homework? You only have to do the first 3 steps. You don't have to do all 8. But you are going to have to do all 8 on the next homework after that.
You're not really selling this.
I know. I just warning you guys. I told you at the beginning of the semester the class is going to get hard. And this is where it gets hard.
I hope you do better with the cars than this.
All right. Well, do you have any questions for me?
I
have
feel
a
sorry for
question.
the people that didn't make it to class today.
No kidding. And the people who left early. So, Allie, how confident are you in today's homework?
A lot more confident than I was last time, because last time I was confused looking for a z-score when I didn't need to look for that.
Give me a number.
I'd say about 93.
93. Wow, that was very specific. Easton, how confident are you in today's homework?
We're gonna go for a solid 95.
95. Good. Janie, how confident are you in today's homework?
Prepare for the low number. Maybe like I will give it a 70% because I know I'm going to overthink things and
Okay.
make mistakes.
How about you, Wes? How confident are you?
I'm with Janie. I've noticed in this class that I do really, really good on the math part of it, but the verbiage and the terminology and trying to hit the statistics talk is not very good for me.
Well, you're not alone in that at all. Okay, this is where, like I said, this is where the class gets hard because we're throwing math at you. So the hardest part is step 4. I'm just gonna tell you that right now. If you can get step 4 right, which assumes that you got the first 3 steps right, you're good. You're usually good, except for the conclusion, because that doesn't involve math. It's just like, now I got to interpret. So, like I said, today was a really, really good introduction to our next chapter. I'm going to post this up. But yeah, so today pretty much, you know what, I will say this. It's pretty much step 3, which is kind of based on step 2. You should probably still get used to listening to your numbers. You don't need to do that necessarily for today's homework, but they will probably ask you to do some interpreting at the end as well. So, but I know this is hard. It's hard for everybody. You're all really smart people, but just know that it's hard for everybody. It was hard for me when I learned this the first time. I was just like, what? So, yeah, just remember your p-value. If your p-value is low, reject the null. That's kind of, I refer to that as the phrase that pays. If you can pay that off, then usually, but some people still mix it up. So, all right, any last questions you guys have before I let you go?
I had one, and it's not necessarily about what we went over today. I just wanted to try to confirm the scheduling for the last 2 weeks of class. In your syllabus, you've got the final being on Thursday, June 25th, from 8 to 9:25. Is that going to be Friday?
It's Friday.
26th?
Yeah, sorry.
Okay.
I thought we were meeting Monday through Thursday when I wrote that, but it will be Friday. So I'm sorry about that. So more than likely, well, let me ask you guys this. The final usually takes 2 hours, and normally I do not do a review before on the day of the final. Normally it's just the whole 2 hours you're taking the final. So I can still do like a 1 hour review and give you 2 hours after for the final. Is that going to interfere with your other classes?
Not with mine, and I'm praying Janie wants a review because I want one too.
Oh my gosh, I will take the review even if it interferes with my other classes.
Well, I'm with you.
Probably. Oh, I need to answer that. You probably, because do you have other, because the other classes I don't want to interfere with their final exams because everything's 2 hours. Everybody's supposed to take them. But because I'd hate for you to miss another final exam because you were taking mine. Does that make sense?
I was going to say congratulations to the people taking other classes in the summer.
No kidding. Yeah, that's crazy. Yeah, one of these is enough. So, okay, so do you have, here, let me stop sharing here again. Do you have any other finals that interfere, Allie?
No, this is the only class that I have, so I would love to have a review before.
Okay. Easton, do you have another one? No?
I don't have any other classes.
Janie?
I have other classes, so I would have to go and check on what the dates are for those.
It will be the last day of class. Do you have another class at 10 a.m.? That's the better question.
Oh, no.
Okay, so it won't interfere. And then Wes?
Yeah, mine won't interfere. This is the only face-to-face class I'm taking. All the rest are online, so the finals anytime that week.
Okay. All right. Okay, so we'll, hopefully the other 4 people, we've only got 8 people in our class, but hopefully the other 4 people, it won't be a problem. So yeah, it will be Friday from 9 to 11, I guess then, because from 8 to 9, we'll have a review. We'll probably try to review on the Wednesday before, but I might need that for class time. We'll see. But I am kind of excited because we did get done with chapter 17 early today. And so that was a huge help to get done so early because I know how hard this is. And so I kind of went over chapter 18. Maybe I'll open up the homework so you can look at it if you want to get started on it. Because I kind of did go over it, but we'll go over it in more detail on Thursday, and if that would be good because I don't know if we're going to cover all the hypothesis tests I wanted to, but anyway, we'll do that. So,
all right, and then so for your next exam, that's going to be sometime next week, right? Either Wednesday or so.
So it will be. We'll just plan on Friday. A week from today, we'll have the exam number 3, and then 2 weeks from Friday. 2 weeks from today, we'll have the final exam.
Okay.
So, all righty then. Well, so I've got. I think I'll try to get the. So the homework's already up. I'll put the due date on there, and then I'll open up chapter 18 if you guys want to get an early start on it too. So quiz on Monday will be chapter 17, and we'll see you all on Monday.
Thank you.
Yep.
Thanks.